Yeah, hello. This is Srinivas. Today I am discussing about the stress. So, what is invest stress? What are the different types of stress? What is the physical meaning of stress? Okay. Now, what is invest stress? So, generally, the book says that the stress is nothing but to force per unit area. But what is invest stress is, for example, I'm taking a member here. So, when you applying the force, there will be stress is developed. But I'm taking this case. I'm taking a trolley, so it's placed on a surface. So when applying the load on this trolley as P, so what happened? So definitely the body will move in the direction towards applied force. So this means here the body will move freely. That means not here the stress is developed. Is it clear? So this is called not a stress. So stress is nothing but so force acting on a member is not always developing a stress. So how the stress is developed even if you are apply the force. So in this case, in the first case, I am applying the force on this trolley. The trolley simply it moves towards the applied force. This means even you applying the force, there is no stress is developed in the body because due to these wheels the body will tends to move freely. So when the body is moves freely, there is no stress is developed. For example, I'm taking as a second case here here, I'm constraining this member. So I'm constraining member. So in this case, I'm again applying the load at the P force. So in here, in the second case, the body does not move along the direction of applied load. So since there may be a stress is developed, there is a internal resistance force is developed in this member. For example, so simply stress is nothing but pain in the member, pain in the member. So in the first case, when you apply the force on this trolley, this member, the body or this member will freely moves along the applied force. So since there is no pain developed in the first case, but in the second case, definitely the body is constrained by someone. So definitely there will be pain is developed. So since stress is nothing but pain in the member. So whenever the pain is developed in the member, definitely there will be a stress is developed. Is it clear? So in the first case, there is no stress is developed because the body will freely moves. So there is no pain is developed in the body in the first case. But in the second case, there will be a chance of developing a pain. So whenever the pain is developed in the member, definitely the stress will be produced. For example, so this is my hand. So when I am applying the force on this my finger, what happened? Or this hand, what happened? Definitely there will be a pain is developed in the wrist. So the junction of this wrist is that some pain is developed. So this means there is a resistance force is developed in this wrist. This means there is a force is generated. So the force is generated on this particular area, that is called stress. So whenever the body is constrained, there will be a stress is developed. Yeah. So when the pain is developed in the member, definitely there will be some stresses is generated. There is an internal resistance force is generated in this wrist. Because of withstanding this load, there will be some resistance to be generated to withstand this external force. So whenever the resistance force is generated, then we call a stress. So now I'm taking another case. So I'm taking a member, I'm applying a force equal to both the cases. So I'm applying the force on the right side as well as the left side. So likewise, I'm applying the force on the right side as well as a left face. So what happened? So definitely there is no resistance force is generated because there is a when the force applied in the right side, that is equilibrium by left side force. So there, since there is no pain developed in that member, so since there is a no stress in this case. In the first case also, there is no stress in this case because there is no pain is developed. Means there is no internal resistance force is generated in this member. In the second case, there is a internal resistance force, means there is a pain developed in this member. Therefore, here the stress is generated. Is it clear? So now I'm taking another case, that is a third case. So I'm taking a member. So I'm applying the force right side with 2p, and the left side I'm applying a tensile force with P. So tensile is nothing but pulling nature, compress is nothing but a pushing nature. So when the load is applying towards out of the member is called tensile force, towards the member the force is applied is called compressive force. So here what happened, there is a P force applied on the left side and the 2p applied on the right member. Since there is an unbalanced force is generated, in the third case, left side also P and right side also P. That left side P is balanced with the right side P. So therefore there is no pain, there is no resistance force will be generated in the member. But as in the case of third case, there is a 2p force is developed in the right side and a p force is developed in the left side. Definitely there will be a unbalanced force is generated. For example, I'm expanding as this, the left side is a p, so the right side is a p plus p. So the left side p is a equilibrium balanced with the right side p. There is a unbalanced force is remaining in this member. So whenever the unbalanced force is there, definitely in the opposite direction, definitely some internal resistance force is generated. So in this case also, there will be a stress is developed. So another special case I'm taking, that is very important case. So I'm taking a cube like this. So this is a special case, fifth case or fourth case. So I'm supplying heat to this member. So what happened? So whenever the heat is applied to the any member, the member is trying to expand like this. For example, this is a two geometry member. So when applying the heat, this means the body is trying to expand like this, or the body is expand like this. In x direction, maybe it may be expand, or y direction it may be expand, or z direction maybe it will be expand. So whenever you are trying to heat any member, any body, definitely the body is trying to expand. So what this case tells that, so the body will freely moves. So whenever the body is a free moves, in the like as a first case, whenever the body freely moves, there is no stress is developed. So in this case also, there is no stress is developed. So when you are taking any member in the nature, if you are trying to supply the heat to the member is trying to expand freely. So it's try to expand freely. So when you are applying the heat, so when you're removing the heat, a body is trying to contract. So whether it is expansion, whether it is a contraction, means the body will try to free from the body or towards the body. That means freely moves means there is no forces, resistance force is generated. So in this case also, so for the in this case there is no stress is developed. For example, I'm taking this body, I'm constraining this body on the right side as well as the left side. So this is a x direction, this is a y direction. So now I am supplying the heat. So what happened? So whenever we are trying to supply the heat, the member is trying to freely expand. So what happened? The member is trying to expand in x direction. It will try to expand in x direction, but this prevention means this restriction, this constraint is opposite. The constraint force is pushing towards the body. So there is a no expansion takes place, or there is no free movement in a x direction, but there is a no restriction in y direction. So the body is freely moves in y direction. So the body is freeze moves in y direction means, so whenever the body is a freeze in move, freely move, there is a stress is not generated. So the body in y direction freely moves. So whenever the body is freely moves, there is no stress. But in the x direction, the body is constrained. So this body is trying to move in this direction, x direction, but this constraint is stops that expansion. Means the body does not freely moves in x direction. So whenever the body does not freely moves in any direction, there will be stress is generated. This means in this case, sigma x is not equal to 0 means there is no zero stress, means there will be a stress in x direction, because in x direction there will be a constraint. So when there is a constraint means the body is trying to avoid free expansion. It stops expansion in x direction, but it's trying to expand freely in y direction. So when there is a y direction expansion, so when the body is moving towards the y direction, it's freely moves. When there is a freely moves means there is no stress. So in which direction? Y direction. So therefore, here in this case, in the y direction, there is no stress is developed. In the x direction, there will be a stress is developed. So application of force is not all, only application of force is not always the developing the stress. Sometimes the heat may be also resulting to develop the stress. This means the application of force not only to develop stress, sometimes the heat also produce stress, but body should be constrained. So application of force is trying to develop a stress, but in the first case, even there is a application of force, but there is no stress is developed. So for developing of stress, so therefore for developing stress, there should be two conditions. First one, so by observing the first case, even you applying the force, in the first case also you are applying the force, in the second case also you are applying the force, in the third case also you are applying the force, in the fourth case, that is a special case, you are not applying the force, but you are applying a heat. So as example of this, here what happened, there will be a stress is developed. So not always for developing stress, not only required the force, it may be a heat also. But in the first case, first case and second case and third case and fourth case, this is a first case, this is a first case, second case and third case and fourth case, this is a fourth case. In the all the four cases, there will be a force is there. Even the force is there in the first case and the third case, there is no stress is developed. So here for developing a stress, there is a two condition. The first one is a body should be constrained. So by observing the first case and second case, in the first case, there is no constraint. So when you are applying the force on this left side, P force, the body will freely moves. There is no constraint. Therefore, there is no constraint means there is a stress, there is no stress is developed. Whenever the body is freely moves, there is no pain in the member. So in the coming from the second case, so but the body in the left side is constrained. When you're trying to apply the force on the right side, so what happened? It's trying to apply the force on the right side. Definitely there should be a constraint. So what happened? The body does not move in the freely. So that does not move freely means there is no pain in the, there is a pain in the member. So here there is a stress is developed. So by observing the first and second case, for developing the stress, body should be constrained. So as a second case. So in the second case only the stress is developed. For first case there is no stress is developed. So as from first and second case, we can tell that for developing a stress, body should be constrained. For third and fourth, And third and fourth, by observing the third and fourth cases, even applying the both the cases, in the third case also we are not providing any constraint, and the fourth case also we are not providing constraint. But in third case there is no stress is developed. In the fourth case there is a stress is developed. So by observing this third and fourth case, even we are not constraining, there will be a stress in developed in this case. So by observing the third and fourth, in third case there is a balanced force is there. The right side P is balanced with the left side P. But in the fourth case, there is a 2P force on the right side and a P force on the left side. This means that left side P is balanced with the right side 1P. There is an unbalanced force is remaining the right side. So here in the fourth case, the stress is developed. So we can say that by observing the third and fourth case, for developing the stress, body should be constrained and there is a unbalanced net force. So by observing the fifth case, this is our fifth case. Fifth case, even you applying, so not only for developing the stress, not only required for the force, even we are giving the heat to the system, there will be a chance of stress. But observing the fifth case, there is no stress is developed, because in the fifth case, the body does not constrain in any direction. It freely moves in X direction, it freely moves in Y direction, it freely moves in Z direction. Moves means here expansion. So expansion takes in X direction, expansion takes in Y direction, expansion takes in a Z direction. But in this case, I'm taking a seventh case. So what happened? So I'm constraining in the X direction. So when I was trying to constrain any member in that particular direction, in that particular direction there will be a stress developed. So that's why in X direction there will be a stress developed. But Y direction there is no stress developed. So the first condition is satisfied. So for developing stress, there should be two considerations. The first one is body should be constrained and there should be unbalanced net force. Is it clear? Okay. So for a definition is nothing but so all this case, in the first case there is an internal resistance force generated, but in the first case there is no internal resistance force generated. In the second case and the fourth case there will be an internal resistance force is generated. That means there is a pain in the member. So we can say that stress is nothing but, so I'm taking this member, so I'm constraining here. So for developing stress, first condition should be constrained. So here I'm constraining this. So I'm applying the P force here. So what happened? For withstanding this force, definitely there will be an internal resistance force is generated. So like this. So this right side applied force is resisted by internal resistance force. So the internal resistance force is acted on this area. So in this area, so therefore stress is equal to internal resistance force by unit area. So internal resistance per unit area is called stress. So many members, it says that stress is nothing but force per unit area. But in the first case, what you observe is even there is a force, but there is no stress, because stress is nothing but internal resistance force per unit area. In strength of materials, we discuss not the external forces. We are interested to find out, or we are interested to calculate the internal resistance force. So stress is equal to internal resistance per unit area. So for internal resistance force, so stress can be denoted as a sigma. This is called sigma. We can denote it as a sigma. So sigma is the units of Newton per meter square, because for force units there is a Newton and area units is a meter square. This is a unit of stress. Unit of stress. Is it clear? So Newton per meter square we can call it as a simply Pascal. Is it clear? There is a stress conversion is there. Anyhow, we can see the stress conversion in our numerical concepts. Okay. Now, so coming to the types of stresses. Types of stresses. So in the first, stress may be normal to the area, or stress may be, yeah. So stress may be normal to the area, or stress may be parallel to the area. So what is meant by normal to the area? What is meant by parallel to the area? So let us see that. So I'm taking a member. So simply I'm here constraining. So I'm applying the force on here, P. So this is a cross section area I'm taking. So this is a cross section area I'm taking. So I'm taking this cross section area. So this is the area I'm taking. So I'm taking out this area. This is the area. So this is my area of cross section of this member. So here I'm applying this force in this direction. So what happened? The force is a perpendicular. Perpendicular means 90 degrees. So if the force is perpendicular to the area, so normal to the area means perpendicular to the area is called as a normal stress. So parallel to the area means, so I'm taking, this is the member. So this is the area. So I'm applying the force on this area. This area. So this is not normal. This is a parallel to the area. So this parallel to the area is called as a tangential stress. Anyhow, here also there is a force P is generated. The P, there will be internal resistance force is generated. So here also I'm applying a force on this parallel to the area P. So withstanding this force, there will be a internal resistance force is generated like this. So this internal resistance is parallel to this area is called tangential stress. So normal to the area is called normal stress. So the stress may be two types, that is equal to normal stress and number two tangential stress. Normal stress is equal to normal force, normal resistance force. So when you are applying the force normal, definitely the resistance force also generated normal. So simply we call it as a normal force or normal resistance force per unit area. So tangential stress is nothing but to tangential force by unit area. So this is called tangential force. This is act on this tangent. So this is called tangential force. These are the two types of stress we have. So that normal stress, this normal stress may be positive or may be negative. This means, so this is a member, this is a constraint. So you're applying the pull force. This is called tensile stress. So which tensile stress? Normal tensile stress. Likewise, for same constraint body, if you are applying the push force P, this is a compressive force or compressive stress, simply normal compressive stress. Is it clear? So stress may be normal stress, the stress may be tangential stress. Tangential stress is a parallel to the cross section area. Normal stress means perpendicular to the cross section area. Is it clear? So what is the physical meaning of stress? So I'm taking two examples. So I'm taking two members. Here I'm taking one member. Here I'm taking another member. So same wise I'm constrained here. Here also I'm constraining in this part. So I'm taking a three geometry area like any body. So I'm drawing as a three geometry 3D figure. So let us say it is a length L. So this is also length L. So I'm taking this is a 1 meter. This is also 1 meter. So this is the area, cross section area. This is the A area, 5 meters square. This is also I'm taking the same 5 meters square. So I'm taking the two geometrically same members. Geometrically same members means length, all the dimensions are same for both the member. But this is a material A, this is a material B. So I'm taking this is a wood. So this is a rubber. So this is a rubber. So two different materials I'm taking. One is a wood, another is rubber, but same geometrically dimension. Geometrically same material. Means geometrically means length and volume and area, everything is same. So here I'm applying the force, P force. I'm applying a 100 newtons. Here also I am applying a normal force P 100 newtons. So which one have the more stress? So which one has a more stress? So people will think of that wood have the more stress, rubber has a more stress, less stress. So when you are applying the force on this member, rubber will freely move, but wood does not freely move. So the people will say that rubber will freely move means there is no stress. The wood does not move freely moves means there is a stress. So this is a not exactly correct. So stress is nothing but internal resistance force per unit area. So I'm taking this is a free body. So I'm taking as so this is a P force 100. So for resisting this P force, definitely there is an internal resistance force is generated. Here also this member there is 100 Newton is applied. For resisting the 100,000 there is internal resistance force is generated. The internal resistance force is always equal to the applied force. This is also 100. So that area we called as a 5 meter square. So this is the area 5 meter square. This is also area 5 meter square. Therefore stress in this wood is equal to internal resistance force per unit area. So internal resistance is 100 newtons and area is a 5. Here also stress in the rubber internal resistance force per unit area. Here also the internal resistance is a 100 and the area is a 5. So what is the stress here? 20 Newton per meter square. Here also stress is a 20 Newton per meter square. So in the both the cases, in the wood, in the rubber, the stresses will be same. So we can conclude that stress in the from example from 1 and 2, stress is a geometry property, not a material property, because this is a wood, this is a rubber. Even the different materials, the stresses will be same. So the stress is not depends on the material. The stress is depends on the geometry of the member. Therefore, stress is a geometry property, not a material property. Is it clear? So this is a physical meaning of a stress. So more the stress means. So for example, the rubber will withstand. So generally rubber withstand the less force, the wood maybe withstand higher force. For example, I'm taking the same cases. This is a wood, this is a rubber. Same area 5, area is equal to 5, area is equal to 5. So I'm applying so wood is resisting more force. So it's maybe 1000 newtons. The rubber only resists only 100 newtons. So what is stress in rubber? 100 by 5 is a 20 Newton per meter square. What is the stress in wood? 1000 by 5, that is equal to 200 Newton per meter square. Means more the stress, more will be strength. Therefore, more the stress of material, more will be the strength. Is it clear? So higher stress, if a material withstand a higher resistance force or higher resistance, high stress, that is called high strength of that material. So strength of material is nothing but it is a maximum load which can carry any material undergoing failure is called strength. So strength is nothing but maximum magnitude of stress we called as a maximum of the strength. Is it clear? Now we will go for, so difference between stress and pressure. So we know that stress is equal to force per unit area. Which force? Internal resistance force per unit area. But pressure, normal force per unit area. So pressure is a normal force. Which force? For example, I'm taking a body. So if you're applying the force on this member, definitely this is a normal. This force is a normal to the area. So that is called external force. This is a external force. So external normal force per unit area is called pressure. Units for pressure also Newton per meter square. But stress is nothing but if you are taking, there is a normal force is applied, P. But withstanding this force, definitely there will be a internal resistance force is generated. Thus, internal resistance force per unit area is called stress. So, pressure is a normal force per unit area. That normal force is always a external force. But stress is a not force per unit area. This is a internal resistance force. Is it clear? So, this is a difference of pressure and stress. Is it clear? So pressure is a cause of stress, but stress is not a cause of pressure. Is it clear? Uh, okay. So the fundamental difference of stress and pressure. So pressure is nothing but external normal force per unit area. So what is stress? Internal resistance force. Underline this word. Resistance force per unit area. And second one. So pressure is always normal to area. So when there is a force in a normal direction, then only we call it as a pressure. For example, if you take this body, if the force acted in some inclination, some angle to the area, that is not generating, that is not called a pressure. So pressure is always normal. So that always, this external force is always perpendicular to area. Next, stress may not always normal. It may be normal or parallel to the area. Is it clear? Next, pressure can be measured. So by using a pressure gauges can be measured by using pressure gauges, but stress can't be measured. It can be calculated because stress is equal to force internal resistance for unit area. If you know the stress, we can calculate, but directly we cannot measure the stress. Next, pressure may cause of stress, but stress may not develop pressure. For example, so I'm taking a tank, a container, so it's having some fluid. So definitely this fluid acts downward direction. So this is a lower part of this container. This is a lower part. So this force is always, this liquid weight is always acted towards this downside of the glass, the base of the glass with P. So the P is a perpendicular 90 degrees. So there is a pressure. Okay. So withstand this high liquid pressure, this base should be withstand. So how it withstand? So withstand this glass, definitely there will be internal resistance force generated. So in which area? In this area. So internal resistance per unit area is called pressure. Normal force per unit area is called, internal resistance force per unit area is called stress. Normal force per unit area is called pressure. For in this case, so pressure may be cause of stress. So due to pressure, there is a stress is developed. But stress is not always developed pressure. Is it clear? So the units of both pressure and stress is same. So don't confuse the pressure and stress. So pressure is a external normal force unit per unit area. So the magnitude of force on the particular member is always normal. That and external, that is called pressure. But stress is a internal resistance force developed per unit area. The internal resistance force is developed due to the external force. Is it clear? When there is an external force, there is a chance of developing an internal resisting stress. So is it clear? So till now we complete the stress. What is the definition of stress? What is the different types of stresses cases, and what is the difference between the stress and pressure, and what is the units of pressure? Okay, in next class we will discuss about the strain. What is inverse strain? What is the different types of strains? What is the different cases of strains? Okay, so